Okay, so we'll come back to the course and that starts straight into the Slido. So the Slido is pretty easy here. I just want to know whether you guys understand what we talk about the binary representations and how to convert the value between hexadecimal, octal, and binary. So the first question is, what is the binary equivalent? What is the equal binary representation for this hexadecimal number A5? So remember to use the technique we introduced in the previous slide. You don't really need to compute the decimal value again and then convert the decimal value back to the binary value. You can directly know the binary value from the hexadecimal value just by knowing how to expand the digit of hexadecimal value into the binary value. And again, let's wait until we have 30 summations. We have 20 right now, 3, 25. Okay, we need 5 more, 28, 32. Let's check out the results. Very good. So over 80% of the submission choose the correct answer. Yes. So actually, this question is not that hard, okay? So you can directly convert 5 back to the binary representation. So how to represent 5 in binary? The only answer is 0, 1, 0, 1. So this is the correct answer. Okay, so let's check out another one. So this is a bit more complicated. So what is the octal equivalent of the hexadecimal number A5? So we have the same hexadecimal number A5, but this time, instead of converting into binary representations, we need to convert it further to octal representation. So how to do that? So to do that, you still need some help by the binary representation a bit. And again, let's wait until we have, let's try more. Let's wait until we have 60 summations. So the value for A is, the decimal value for A in the hexadecimal number is 10. Okay, we just need 6 more. We need 3 more to 1. We need 2 more. 1 more. Great. Oh, interesting. Okay. So, but we still have over and then half of the summation choose the correct answer. So yes, the correct octal representation for this hexadecimal number is 2, 4, 5. So what you need to do is to first convert this hexadecimal number into binary representations like this, and then group those binary digits 3 together. So we group 3 digits together to form the octal representation, right? Because 8 is 2 to the power of 3, so 3 digits in the binary representation can represent 1 digit in the octal representation. So that is why if you follow these computations, you can get the final correct number, that is 2, 4, 5. So if you get it wrong, don't worry. It just means that you have another chance to learn. So I will recommend you write it down and really write each step of the calculations. Then you will know why 2, 4, 5 is the correct answer. Okay, so let's continue. So after talking all these different constants, integer constants and different type of the integer variable. So how can we read and write all these different type of integer? So to read and write the unsigned integer using scanf and printf, we need to add some special conversion specifications. For example, if we want to read the read the number in the decimal format. So we want to strictly say that, okay, this value need to be decimal format. To do that, instead of writing %d, we need to write %u. And for the octal number, we need to use %o. For the hexadecimal number, we use %x. So we can use these different conversion specifications to read and write the integer constants in different form. And if we want to write down the short, unsigned reader. Okay, so U is especially for the unsigned integer. So it is not just for the decimal number. So to read the unsigned integer, we need to write down %u. So, but when we use %u, that means that we read this unsigned integer in the decimal format. So that is the correct meaning of %u. Sorry that I just read too quickly. Okay. So that is for the unsigned integer. So how about the short integer? Because we also said that we can declare the short integer. So to tell the scanf and printf that this number should be read and write as a short integer, we just need to add the letter h in front of the other letter we introduced in the previous slide here. For example, if we want to say that this is a short integer in the decimal format, then we need to write down %hd. So now you know the meaning of d, right? So the %d, the meaning of d is for decimal. So that means that if we use %d to read the number will be in the decimal format. So if we add the h in front of %d, that means it is a short integer number in the decimal format. And if we want to read the value for this short unsigned integer variable I, then we just need to write down hu, because u is for unsigned integer, h is for short. And we can also add the h in front of old and add x, so that will mean that this is a short integer in the octal format or in the hexadecimal format. And that is, so actually this is the same for the long integer. So instead of writing, put the letter h in front of these specifiers, we put down the letter l in front of these conversion specifiers if we want to read it as a long integer. So l is short for long. So you can see if I have an integer, long integer l, then I can use the ld with the scanf and printf to read down to read the long decimal number and write the long decimal number. And if we have a long integer value, integer variable, then we just need to put 2l in front of these conversion specifiers. So we have 2l here for the long integer variable. So the 2L here is the name of the variable. Okay. So that is the all for the different type of the integer variable, different type of the integer constant, and how can we use scanf and printf to read and write those integer with the different types. Then the next topic I'm gonna talk about is the concept of integer overflow. So integer overflow happens because now we know that different type of the integer have the maximum value, right? So if we store the value that is larger than its maximum value to the integer, the thing that will happen is called integer overflow. So, for example, when we use the arithmetic operator like plus, minus, or multiplication on integer, sometimes the results will be too large for the integer to store and represent. And if the result cannot represent as this integer variable, we will say that the integer overflow has occurred, the integer overflow happened. So the result, so that means that if the result is too large or too small for the integer, those two things will also cause integer overflow. So this is, I'm not sure whether you guys still see these things on your motorcycle or the car. So you can see so the maximum number in this picture, the maximum number, the device that this picture can represent is 99999, right? And if we add one more value to this maximum number, it will result in the situation here. So because it is already exceeds the maximum number, and that this device, the value here cannot represent this large value. So we will lose the value we want to store if integer overflow happened. So the consequence of integer overflow will actually depend on whether the integer variable were signed or unsigned. So when the integer overflow happened for the signed integer, so signed integer means that the leftmost bit is reserved for the signed bit. So if an integer overflow happens for the signed integer, the result will be undefined behaviors. And we actually talk about all the negative consequences of undefined behavior in the expression 2. So we also say that undefined behavior is the thing you want to avoid. So please make sure to avoid integer overflow when you use the signed integer. And, and so that is the case for the signed integer. How about for the unsigned integer? So if the integer overflow happened for the unsigned integer, actually the result is defined. So it will not cause undefined behaviors. So what happened is that we will get the correct answer modulo by 2 to the power of n. So the n represents the number of bits used to store the result. So, so to remind you about how to calculate the module here, so modules in Chinese called 除模. So actually, if we calculate 3 module 2, the result of 3 module 2 is 1. So it will be the remainder. So let's check out the example here. So if we add 1 to the unsigned 60-bit integer and integer variable, and this variable have the number here, and we know that this number is in this case, it's the maximum number this variable can store, and we add 1 to it. So what will happen is that if we print out the value stored inside the integer after the addition, the result, the value stored inside the variable will be 0, because we just because what we did is that this is the maximum, this is the maximum number of the 16 bits unsigned integer, right? And then we add 1 to it. So this is the value we have now, but because the value is overflow for this integer type, so we need to modulate it by 2 to the power of 16, because this is a 16-bit. And by the definition here, we need to, the number of n is the number of bits this variable can use to represent integer value. So that is why we put 16 here. And because -1 and +1 will become 0 here, so what we do basically is to calculate 2 to the power of 16 mod to the power of 16. So that is why the result is 1. So this is how you can know the outcomes if the integer overflow happened to your unsigned integer. But I will say just in general, please avoid integer overflow, because when the integer overflow happens, that means that your program don't behave like the way you want it to behave. So actually, I don't think we have enough time to introduce the last two parts. We have char and float here. So I will say, let me see, float types. Okay, so I will like to introduce the float and char in this Thursday. And I will say that today's course is end, so that's all for today. And thank you for coming, and I will see you this Thursday.